In this lesson, we're going to be working on the fundamental counting principle. And the fundamental counting principle is a way that we can figure out how many ways an event will happen. So for example, if you had this situation, you were at a deli and there were 4 kinds of meat: ham, turkey, roast beef, and pastrami. And there were 3 types of bread: white, wheat, and rye. How many ways could you order a meat sandwich? So you can see that one way we can figure this out is with a tree diagram. So first we would list all the meats, and then for each meat we would list the bread, and then that would give me the number of sandwiches. So there would be 12 sandwiches when I count at the end. But you can see that there might be a problem with that, because what happens if we have a much larger amount of offerings? For example, let's say we put in not only the meat, but we had toppings as well. Our tree diagram would get huge. But maybe some of you figured out that we could simply multiply the meat choices by the bread choices, and that is called the fundamental counting principle. So let's take a look at another example. At a restaurant, you have a choice of 8 different entrees, 2 different salads, 12 different drinks, and 6 different desserts. You want to know how many different dinners could have 1 salad, 1 entree, 1 drink, and 1 dessert. All we need to do with the fundamental counting principle is simply multiply the choices together, and that would tell us how many different meals that we could order with 1 from each category. In this case, there would be 1,152 different meals that we could order at this particular restaurant. Let's look at another example. Let's say that we are talking about how many different 7-digit phone numbers are possible if the first digit cannot be a 0 or a 1. So first of all, we know that we have 7 digits for a phone number. And in our system, when we're talking digits, we can only use the numbers 0 through 9. Because all of the numbers in our number system are made up of those numbers. And if we were to count from 0 to 9, we know that we have a total of 10 different digits in our system. Now, if we say that our first number cannot be a 0 or a 1, that means I only have 8 numbers to choose from. But it says nothing about repeating, and it says nothing about describing the digits for the other numbers in our phone number. So that means for all of the other numbers in our phone number, we would have 10 digits. So if we multiply all of these together, there would be 8 million different phone numbers that are possible with a 7-digit phone number, and where the first number cannot be a 0 or a 1. So please remember, when we're talking digits in our system, we only have 10 digits in our number system that go from 0 to 9. Next, how many ways can we arrange the letters in the word bad? So in the letters bad, B-A-D, we have 3 letters. And how many ways can we arrange these 3 letters? Well, in the first blank, we would have 3 choices, either a B or an A or a D. Then depending on which one we picked, we would only have 2 choices in the next blank. And finally, we'd only have 1 letter left. So there would be 6 different ways that we could arrange the letters in the word bad. Now, another thing that we have to remember before we move on is if I were talking about, say, letters in a password, if it asked you how many choices of letters, remember in our English system, there are 26 letters in the alphabet. So it's important to remember that if I ask you to pick a letter, that you would have 26 different choices. So let's take a look at our next example. This example is called a factorial. A factorial could have been used on this particular problem with the letters bad, because what the factorial says is it takes the product of all the integers from 1 to whatever number we're talking about. For example, the number 6 factorial. 6 factorial simply means 6 times 5 times 4 times 3 times 2 times 1. Now, the problem is that if we were to have to do that with really large numbers, it's going to take us a while. So you can use Desmos on your iPad to evaluate this particular function called a factorial. And here are the directions. If you open Desmos on your iPad and you type in the number 3, then you go to ABC, you'll be able to find the factorial symbol, which is simply an exclamation point. And then when you type in 3 factorial, you would type in the 3, the ABC, which gives you your menu, the factorial, which is the exclamation point, and you'll get an answer of 6, which we know 3 times 2 times 1 is 6. So if you were to do that with each of these, 0 factorial is the strange one. That's a 1. But 1 factorial is 1. We already know that 3 times 2 times 1 is 6. 7 factorial, a very large number, 5,040. And then when you do 8 factorial divided by 5 factorial, you can use the Desmos operation, or I want to show you what's actually happening. Eight factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial means 5 times 4 times 3 times 2 times 1. So what the calculator is actually doing is it is dividing out, because any number divided by itself is 1, the common factorials in the numerator and the denominator. And then it's only multiplying 8 times 7 times 6. So you should get 336 if you use your application on your Desmos. All right, next question. In how many ways can we arrange the letters in the word math? Math has 4 letters. 1, 2, 3, 4. So we could, on Desmos, simply do 4 factorial, which would be 24. Or we can use the fundamental counting principle. I have 4 choices to pick from. Once I pick a letter, I have 3 choices. Once I pick a letter, I have 2 choices, and I'm left with 1 choice. 4 times 3 is 12, times 2 is 24. Either one will work. You can use either method. Next question. Again, same thing. You have 5 photos and you want to put them on the shelf. So if I pick the first photo, I have 4 choices left, then 3 choices, then 2 choices, then 1 choice. There would be 120 ways that I could arrange the photos on the shelf. Or I can simply do 5 factorial, which I can use my Desmos application to get 120. All right, last. We could use our fundamental counting principle or our factorial if we needed to find probability. And that's how this ties in with our previous unit, or previous lessons. So there, in a town parade, you'll ride a float with your soccer team. There are 12 floats in the parade and their order is chosen at random. Find the probability that your float is first and the float with the school course is second. All right, so there's going to be 2 choices or 2 spots that you're choosing. You have 12 choices for your first and 11 choices then for the chorus, which means there are 132 different combinations in the parade where you could be first and the chorus could be second. But I'm looking for probability. So this is what I want, but I also need the total. So the total is going to be 12 factorial for the total amount of order that we could do in the parade. And that is a huge number. You can put in your calculator or use Desmos. 479,001,600 different ways that you could make the arrangements in the parade. So to find that, we would take 132 divided by 479,001,600, and that would be the probability that your float would be first and the choir would be second.